Hi everyone and welcome to the internet. What we're going to be doing in today's lesson is having a look at the concept of nutrient cycling. And what I mean by that is we're going to be able to describe how different nutrients actually cycle through an ecosystem. To start us off though, let's begin with our usual starter questions based around our previous lesson. So today you've got 3 questions on the screen. So have a go answering these 3 questions in your books, and I'm going to give you about 4 minutes to do that. Let's mark those answers then. So for question 1, we were looking at different ways that biomass could be lost from a food chain. So you can give yourself a mark for any of these that you got right there. Excretion, egestion, not all of the organism being eaten, or respiration. If you described either of those processes that we've just used the word excretion or egestion for, then that would also be fine in most cases. Obviously the time that wouldn't be true is if they asked for the scientific term that means such and such a thing. For question 2, the answer is no, it is not always pyramid shaped, and the reason for that is that one large producer can support many smaller primary consumers. So 1 mark if you said no, 1 mark if you described the reason why. And then for our final question, which for some reason I've labelled as 2 again, it's actually question 3 at the bottom there. The answer is yes, they are always pyramid shaped, 1 mark for that one. And the reason is that biomass is lost at each trophic level, so the lowest bar will always be the largest bar. So 1 mark for the yes, 1 mark for the explanation. So add up your scores for me and give yourself a total. Let's start off with some real basics about nutrients and how they're cycling through. So what I've got for you there are 3 sentences on the screen with 3 missing words. And the words that are missing are given to you in the red box at the bottom. What I'd like you to do is have a go at filling in the missing words as you write those sentences in your book for me. So I'll give you about 3 minutes to get those 3 sentences and the missing words written in your books. Let's double check to make sure we got the right words in the right places then. So plants get the nutrients they need from the soil, give yourself a mark for that. These are passed to animals when the plants are eaten, tick for that one. And when organisms die, the nutrients are returned to the soil by decomposers, a tick for that. So add it up and give yourself a score out of 3. Obviously any of those words you didn't get right, make sure you have got the right word written in now. So when we're looking at these different nutrients cycling through an ecosystem, what we find is there are going to be living components and non-living components. So these cycles are split up into these two different categories, if you like. So what I've got for you there are 4 different parts that I'd like you to categorize as either living or non-living. So next to each one, obviously jot down what it is, and then you can put an L for living or NL for non-living, or you could write living and non-living. It's up to you how you do it, but label them living and non-living. I'm going to give you just about a minute and a half to do that. So what we actually find then is that there's only one non-living component in the list I gave you, which is the inorganic molecule or ion. Now, where we see the word organic, then that refers to something that is a living thing, basically. So what we can do is have that real simple check. If it says organic, it's living. So organic molecules in producers, organic molecules in consumers, organic molecules in decomposers, all of those are within living things. Whereas the only non-living component is the inorganic molecule or ion. So give yourself a mark for each of the 4 you got right, just so that we know which are the living, which are the non-living. Obviously, correct any that you didn't get right. The next thing I'd like you to have a go at then is we've got a little flow chart here showing how those 4 different categories, if you like, are linked together within our ecosystem. So it's showing how some kind of nutrient is going to cycle through that ecosystem, through those 4 different stages. Now, what we've got on there are the living and the non-living, represented by the circles and the rectangles. And then what I've got are 4 blue boxes floating above the arrows. Now, what I'd like you to have a go at doing is do a sketch of that diagram and then add in the phrases in the bottom right: death, absorption, feeding and digestion, that's 1, and decomposition, onto the right blue box area. So because I'm asking you to do that little diagram, obviously I'm going to give you a couple of minutes to have a go at this. Let's make sure we got those in the right places then. So if we start at the top with the inorganic molecule or ion, then that is going to be absorbed into the organic molecules in the producers. So we've got absorption going between those two. The organic molecules in the producers will be transferred into the organic molecules in consumers through the processes of feeding and digestion. What we then find is both producers and consumers will die, so that goes to death, and that means that we've then got the organic molecules in the decomposers, and hopefully we worked out that decomposers carry out the process of decomposition, and that then returns the organic molecules to the inorganic molecules that we'd find in places like the soil. So give yourself a tick for each of the 4 you got right. If obviously any were in the wrong place, make sure you correct it so you know what those different processes are that allows it to cycle throughout the ecosystem. Over today's lesson and our next lesson, we're going to be having a look at 3 different cycles. We're going to look at 2 of them today and the 3rd one in our next lesson together. So the first one we're going to look at is the water cycle. Now this is something that I'm pretty sure you will have encountered back at primary school, so you may have to stretch those brain cells back a little way to try to remember when you were knee-high to a grasshopper, and see if you can actually explain how water is cycled here on Earth. Now if you want to do a diagram, by all means feel free, and I've given you 5 key words that I'd like you to try to use. Now don't just write down those 5 keywords and think that's an explanation. Maybe explain what those words mean and then how they tie together in the cycle. So I'm going to give you about 3 minutes so you can have a really good go at explaining how water is cycled on Earth. Okay, let's have a little look at our water cycle then. So this is the kind of easiest diagram that I've seen for a while that we can use to actually explain it. Now what we're going to do is we're going to start in the top right with our precipitation. So we've got our clouds up in the top right. We should be quite used to those at the moment living in England. And what we actually find is that we get precipitation, which is basically the flashy scientific word for it rains. And it rains a lot, let's be honest. So what we actually find is that the reason it rains is because the water droplets that make up the clouds get heavier and then they fall as rain, or if it's cold enough, snow or hail. Now what we can see there is that rain is obviously going to come down from the clouds and hit the surface. What we then find is we get our second process called percolation, which is where the water is going to trickle through these tiny gaps that we find in soils and in rocks. So basically that water that hits the surface is going to sort of seep in between those cracks and gaps between the soil and the rocks, and it ends up in our underground water system called the water table. Now some of you might have heard about that in geography, and it's the kind of thing that when it rains an awful lot, then it's why we suddenly get rivers re-emerging, because all of a sudden that underground supply gets full and rivers pop back into existence. Hence why you don't buy one of these new build houses built on something called Duck Pond Lane, for example, because, you know, it was once a duck pond. Therefore, rains enough, it's going to be a duck pond again. From the percolation, we can see it's in the water, in the ground, and therefore we can actually have plants taking it up through their roots. Now, if plants absorb it, then they're going to lose it through a process called transpiration, which is a brilliant link back to one of our earlier biology topics. Transpiration, hopefully we know, is the loss of water vapour through the aerial parts of a plant, if we're going for our flashy, fully appropriate to A-level definition. And that means we're going to lose the water from within the plants to the atmosphere as water vapour. You'll also notice there's a little label there that says surface runoff. Now that just tells us that not all of the water is actually going to seep down into the ground. Some of it just runs straight off the surface. And that's particularly true in places like towns where it's all tarmac and concrete. Now all of that water that's going to run off and trickle through the actual water system within the earth itself ends up eventually in places like the seas and the oceans. Then what we find is we get the process of evaporation happening, where the sun is going to heat up the surface water on the earth, and that's going to change the water into our water vapour, and it rises up into the atmosphere at that point. As it rises, then it gets cooler, because as we go further up in our atmosphere, the temperature drops, and we will then end up with condensation occurring, because that water vapour condenses back into liquid water droplets, and we produce our clouds. And as those clouds move and they cool, then it will eventually get back to precipitation again. So what we can see there are those processes all tied together in that water cycle. So if you obviously want to do the sketch of the diagram, then I'd suggest hit pause on the video and just go through and create your own version. If you got that explanation in words, then you don't need to worry. The diagram isn't essential, but knowing what those words are and what they mean is really important. So if you need a bit of time to get that done, hit pause so you've got a chance to get it in your books. Our second cycle is the nitrogen cycle. Now, one of the things that hopefully we know from Key Stage 3 is that nitrogen is the predominant gas within our atmosphere. It accounts for 78% of the air that you are currently breathing in. Now, nitrogen is actually really important to us as living things because we use that nitrogen to make the DNA within all of our cells and to make the proteins that we need to build cells. Now, we can't actually absorb the nitrogen we breathe in from the air into our body and use it to make DNA and proteins. It just doesn't work. We can only take up those nitrates by our plants. Now, what we're going to do is we're going to have a look to see how it is that the nitrogen in the air can then end up in the plants and eventually end up in us. But make sure you've got those 3 sentences written down, because one of the things they do like to ask you is what is nitrogen used for, and that would be making DNA and proteins. The diagram we've got here, and again, if you want to copy it, I'd suggest that you pause the video when I've finished giving you the rundown on it, is showing us the entire nitrogen cycle. Now, what we're going to do is we're going to start at the top with that blue box that says nitrogen in the air. So hopefully we know nitrogen in the air is a diatomic molecule, goes around as N with a little subscript 2. So 2 nitrogen atoms joined together. That's our nitrogen in the air, 78% of it. Now, what we find is that that nitrogen in the air is then going to be taken in by nitrogen-fixing bacteria. So that's our first type of bacteria. They take in the nitrogen and they convert it to nitrates. Once we've actually converted it into nitrates, then our plants are able to absorb it through their roots, and they will then be able to use those nitrates to build the proteins. And the proteins then obviously go into the plant's biomass. So at that point, what we've done is we've got the proteins in our plant, so that nitrogen is in the plant. We then transfer those nitrogens from the plant to the animals through the process of feeding. So animals are going to eat the plants, and that transfers the plant proteins to the animal proteins, and we then use it to build up extra biomass in our animals. What we will also find is happening in our animals then is they're going to be excreting, because let's be honest, if you walk through the countryside, they do a lot of that. And as a result of that, we're getting some nitrogen compounds returned to the soil at that point. Now, it's not a case of it all just instantly becomes useful. We've got other bacteria involved here, and these ones are called decomposers. It's not just bacteria though, we've also got fungi that are decomposers. So what they're doing is they carry out the process of decay. So they will break down those chemicals in the waste made through excretion, and also any dead animals and plants. And what they're going to do is they're going to convert those proteins into ammonia. What we then find, the ammonia is then going to be taken in by the nitrifying bacteria and converted into nitrates, and those nitrates can then be absorbed by the plants again. There's one other type of bacteria that's in this cycle, which is the denitrifying bacteria, and their purpose is to release nitrogen back into the atmosphere. So they convert the nitrates into nitrogen, and then round and round we go again. So if you need to copy that diagram, then by all means pause the video. But what I've got for you on the next part of this lesson is a quick summary about what each of those different groups of bacteria do. So what they're changing into what. I would suggest we get that diagram done though, because it does have those other processes involved. So here we go then. This is the quick guide, if you like, to the 4 types of bacteria that are critical to our nitrogen cycle. So the first group are bacteria and fungi together. These are our decomposers. They change the proteins into ammonia. The second group are the nitrifying bacteria. They take that ammonia and turn it into nitrates. The nitrogen fixing bacteria turn nitrogen gas into nitrates, and the denitrifying bacteria turn the nitrates into nitrogen. So these 4 groups of microbes are really important that you know their names and what they're converting into what. If you've got that, you've got the vast majority of the nitrogen cycle sorted. The only other bits you then need to think about is just mentioning the fact that animals excrete, plants and animals die, and animals eat plants. The rest of it is pretty much there. So what we need to do first of all is learn those 4 groups of microbes, what they convert into what, and then look at building it into the nitrogen cycle. One of the best ways that I think you can learn these different cycles that we've looked at today is to get a drawing or an outline of them and then stick either post-it notes or a little flap of paper over it so that you've got the key wording, if you like, covered up. Then what you can do is you can just sit there with it and then just test yourself. See if you think you know what that first one is. Check by moving the little flap down and seeing if you got it right. And the more you do that, the better you will get and the more it's going to stick in your heads. So I'll leave this slide up for another minute just to give you a chance to finish those off if you've not already got them. Last thing for today then are the plenary questions. So 4 questions for you to have a go at. I'll leave these up for about 3 minutes today, but obviously if you need longer then just hit pause on the video and take as long as you need to have a go answering them. As always, you can find the answers to the plenary over on my website, sciencewright.weebly.com. You'll also be able to find that under the Internet tab. Just select the week that we're in, and then you'll be able to find things like the lesson PowerPoints, the answers to the plenary, any additional work, and if there's any little experiments I thought you could do at home, then they're there too. So have a look and get using that.